All right, so this video is about the week 14 spiral review. And so week 14, week 15, and week 16 will all look exactly the same. So you want to pay attention and look at each of the problems if you get stuck on anything. All right, so I'm going to go through each one. I'm starting with number 1. So number 1, it says a recipe calls for 3 cups of flour and 2 cups of sugar to make 1 batch. How many cups of flour and sugar would you need to make 4 batches? So I want to make 4 batches of the recipe, which means I'm going to have to basically repeat my ingredients 4 times. So we learned in class that you could do it either using a double number line or a table. So I'm going to do it using a table. So if I set my table up and I have flour and I have sugar, and then my original amount is that there's 3 cups of flour and 2 cups of sugar for 1 batch. So I'm gonna put that in there, 3 and 2. And then it tells me that I'm doing 4 batches. So that means I've got to take my flour and my sugar and multiply it by 4, which means 3 times 4 would give me 12 and 2 times 4 would give me 8, which means I'll need 12 cups of flour and I'll need 8 cups of sugar to make 4 batches. I could also have done a double number line, and then this will be my flour line and this will be my sugar line. And you know we started with 0, 0. We know 1 batch is 3 flour, 2 sugar, and then I just have to keep going on my double number line. So the 3 will go up to 6 and the 2 goes up to 4, and that would be 2 batches. And then if I make a 3rd batch, my 6 goes up to 9 and my 4 goes up to 6. And then if I make another batch, my 9 goes up to 12 and my 6 goes up to 8. Because on the bottom line, I'm skip counting by 2s, and on the top line, I'm skip counting by 3s. And you see, again, 12 cups of flour, 8 cups of sugar. All right, so question 2. So Monica has X beanbags. She gives 6 away. Which of the following expressions could she use to model the situation? So we're just trying to model the situation, not answer it. So we're looking for which one of these expressions is basically modeling that she has X and then she gives away 6. So she has X and she gives away 6. Well, if I'm giving something away, that means that would be subtraction. And it's getting subtracted from whatever she has. And she has X, so then it has to be X minus 6, which goes with answer choice D. All right. Question 3, it says find the surface area of a cube with an edge of 12 inches. If you get stuck, use the net to help you. So I've given you this net, which is basically the cube if I unfolded it. And remember, a cube has 6 faces. They're all squares. They're all the same size. And we know the edges are 12. So if I were to fill in the edges, all of my edges are 12 because on a cube, all the edges are the same. And then I want to find the surface area, which means I've got to find the area of each surface. So I got to find the area of each one of these squares. So I'll do base times height, which would give me 144. And the nice thing about a cube is once you know the area of one side, you know the area of all the other sides. So all the sides would have an area of 144. So when I get my final answer, I'm going to do 144 times 6. And 144 times 6 gives me 864. And this was one of the questions where you could use a calculator to get your final answer. And so our final answer is 864 inches squared. All right, so let's go to the next one. What is 75% of 28? So I'm looking to find this percent of this number. So in class we talked about you have to figure out, well, what have you been given? Well, I know that 75% is the percent. And I know that because it's a percent sign. And then I have to be thinking about what is the 28? Is 28 the whole thing or just a piece? Well, 28 is the whole thing. because I'm trying to get 75% of 28. So I'm trying to get 75% of this whole number of 28. I'm trying to figure out what piece. So that means to get my final answer, I'm going to do 75% times 28. And I can do that in my calculator. So if I do 75% times 28, it's going to give me 21. So that means 75% of 28 is 21. All right, number 5 says a 10-pound box of apple costs $12.50. What's the unit rate? Well, the unit rate is the rate for one. And so if I want to know the unit rate of the apples, basically I'm trying to find, well, what is basically the cost for one apple? So I'm looking for the cost for one apple. Well, I know that it's $12.50 for 10. So if I take $12.50 and divide it by 10, then that gives me $1.25, which means I am paying $1.25 per apple. And that's my unit rate. Remember, unit rate is always the cost for one. And hopefully you guys could see that. I don't know if it was off the screen or not. All right, so let's go to number 6. All right, during a basketball game, Jada made 12 field goals. Each field goal was worth 2 points. Jada also made three free throws. Each free throw was worth 1 point. Which expression could be used to determine how many points Jada scored? So I'm looking for an expression here that describes what happened in the problem. Well, I know she made 12 field goals and each field goal was 2 points. So I know initially that's gotta be 12 times 2 because she made 12 and then each one was 2 points. And then the next thing that happened in the problem is it said that she made 3 free throws and each free throw was 1 point. So now, in addition to that, she did 3 free throws and each of them was worth 1 point. So I can show that as multiplication. And then if I'm trying to figure out how many points she scored, well, that means I'm going to add up the points that she made with the field goals with the points that she made with the free throws. So that means I have to add these points together. So this expression plus this expression would basically be what I would use in order to figure out how many points Jada scored. And so that means now that matches answer choice B. All right, question 7. A supply storage room has a total of 800 shoes. If 240 of them are sandals, what percent are sandals? So this question is asking me what percent of the shoes are sandals. So that means I'm looking for the percent. So I have to look at what I've been given. Well, I know 240 are sandals and there's 800 total shoes. That means that 800 is the whole and 240 is the part. And I'm looking for the percent. So in this situation, I know I take the part, 240, and divide it by the whole, and it's going to give me a decimal. So when I divide that in my calculator, it's going to give me 3/10. When I get my answer, though, it's not already in percent form. It's in decimal form, and we learned that we've got to change that to a percent. So one thing you can do is by adding a 0 to the end, we know that a percent is the same as 100th. And if I have 30 hundredths, that means I have 30%. The other way I can do this is multiply by 100, and it also will give me 30%. So 30% of the shoes are sandals. All right, number 8. What is 12 divided by 1/2? The hint is how many 1/2 size pieces are in 12 holes. So if I go by the hint, I need to start with 12 whole. So if I have 12 whole pieces, so these are my 12 whole pieces. I want to know how many 1/2 size pieces are in 12 holes. So I'm going to basically cut my holes into halves. And now I'm looking to see how many 1/2 size pieces do I have. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have 24 half-size pieces in 12 holes. Number 9, how are 4/10, 4/5, and 4/20 ordered from least to greatest? So I want to order these fractions, 4/10, 4/5, 4/20. Before I can put them in order from least to greatest, I need to get a common denominator. I need to get them into the same number of pieces because it's hard to compare them like this. So I'm going to start by doing 4/10 and getting a common denominator. And so when I look at 10, 5, and 20, I'm looking for their least common multiple, and that's going to be my common denominator. So the multiples of 10 are 10, 20, 30, 40, 50. And then the multiples of 5 are 5, 10, 15, 20, 25. And the multiples of 20 are 20, 40, 60, 80, 100. And I'm looking for the smallest number they have in common, which is 20. So that means 20 is my common denominator. So for each one of these, I'm trying to get them to a denominator of 20. Now this one already has a denominator of 20, so I don't have to change it, but I am going to have to change 4/10 and 4/5. So for 4/10 to get it to a denominator of 20, I have to see, well, how did I get from 10 to 20? Well, I multiplied by 2, and I have to do the same to the top, which would give me 8/20. And then for 4/5, I had to multiply by 4, which would give me 16/20. So now what I'm comparing is 4/20, 8/20, and 16/20. They all have a denominator of 20. So if I want to put them in order from least to greatest, I'm looking for which one's the smallest. So think about if I had a pizza with 20 pieces on it, which would be the smallest portion? If I had 4 out of 20, 8 out of 20, or 16 out of 20 pieces. Well, the smallest one would be if I had 4 out of 20 pieces. Then the next one would be if I had 8 out of 20 pieces, which was originally 4/10. And then the next would be, the largest is if I had 16 out of 20 pieces, which was originally 4/5. So least to greatest is 4/20, 4/10, and then 4/5. All right, last question, number 10. So for number 10, Jesse was doing inventory in the science lab and made a table to compare the capacity. Capacity is volume, or how much something can hold. So to compare the capacity or the volume of 4 containers. According to the table, which container holds the most? So container 1 holds 3.3 liters. 2 holds 300 liters. 3 holds 1/5 liters, and 4 holds 3.25 liters. I want to compare these, but they're in different forms. These are in decimal form, and these are in fraction form. So before I can compare them, it's easier if I get everything to the same form. So it's easiest if I change everything to a decimal. So 3.3 is already in decimal form. 300ths is not, but if I read it out loud, it says 300ths, which has to be 0.03. Then 1/5, I can change that to a decimal by dividing the numerator by the denominator. So if I were doing this, I would do 1 divided by 5. I'm going to do that over here. So 1 divided by 5, and that's going to give me 2/10. Then I know that the other containers, we know that there's another container that's 3.3. We know there's another container that is 300ths, and we know there's another container that's 3.25. Now again, I still am not ready to compare these because these go to the 10th place, this goes to the 10th place, and then these go out to the 100ths. If anything goes out to the 100ths and the other ones go out to the 10th, that means there's not a fair comparison yet. I need to get them all to the 100ths place. So I'm going to add a 0 to these two numbers so that it's easier for me to compare them. Now they're all going out to the 100ths place. So I'm going to start by comparing the whole numbers first. When I look at the whole numbers, I'm looking for the biggest whole number. Well, 0 is definitely not bigger than 3. So these definitely can't be the largest. So that really means I'm just comparing 3.30 and 3.25. Well, if I'm comparing them, 3 and 30 and 3 and 25, well, which one is bigger? If I think about it in terms of money, $3.30 is more than $3.25. So that means this is my biggest container, which means container number 1 is actually the biggest container. So container 1 is the biggest container. All right, so I hope this helped. Remember, you don't have to watch the whole video. You simply need to look at the questions that you need help with, and then try those questions on week 15 and week 16, and hopefully you'll have an easier time with them.